Hello and welcome to Fibro-Solar for this new training session. Today we are going to look at Fibro-Solar. I am Stefan Aroe and I have been working in the design office since 2011. I will introduce you to the parts, the different components. We will also have a discussion with the slideshow, and then we will also see some presentations of the Fibro-Solar system is certified with an ETN for technical approval, new. We also comply with DTU 4037 and have a maximum purlin spacing of 1,385 on a 5 or 6 wave corrugated fiber cement system. Of course, for each project, we will provide you with a calculation note if you do not meet the purlin spacing requirements regarding the purlin spacing. The system weighs about 1 kilogram per square meter, excluding the module. It is compatible with all types of frameworks, whether metal or wood. This system is designed exclusively for modules installed in landscape orientation. Be careful with fiber cement. You can install it on the 2nd, 3rd, 4th, 5th, and 6th waves. The overlap wave, indicated here by the orange arrows, is strictly prohibited for any kind of fastening. By default, fiber cement is fastened on the 2nd and 5th wave, regardless of the number of waves in the fiber. Cement, whether it has 5 or 6 waves. It is also possible to adapt it to PST, but we have no certification for this type of fiber cement. We guarantee watertightness based on our tests. There is just a small difference between the corrugated sheet and the PST. The seal is 10 millimeters for the PST and 3 millimeters for the corrugated sheet on our supports. This support, which can also be found on the corrugated sheet for the ridge, may be, as you will see, on the fiber cement in Tolzinge and not in the shape of corrugated fiber cement. Before starting a final layout, before installing your system, of course, we've already done a preliminary study. So we need as much information as possible to carry out your preliminary study. The exact location or GPS coordinates, the structural plans with the type of purlin and how your fiber cement was fastened. So don't hesitate to send us photos, whether it's a single pitch roof, a double pitch roof, or if there are any adjoining buildings. For the photos, what we're mainly going to look at is your ridge, how it was finished, and especially whether we'll be attaching all the way to the ridge, since with the Fibro-Solar system we can do that. Either on the zinc sheet at the ridge or on the corrugated ridge, but of course we need to know how it is finished in order to adapt our support. Often on fiber cement, on old frameworks like I-beam purlins or thick purlins, you might have hook bolts holding your fiber cement or staple hooks. Be careful, you won't be able to use these waves to secure your installation. Or else with the hook bolt, maybe bring the support as close as possible so you can reach the purlin with the self-drilling fastener. As for the hook, well, you'll have to. We're lucky with fiber cement. Simon, where the gaps between the waves are around 18 centimeters, we can shift by 1 wave. But be careful, I repeat, especially not on the overlap wave. That is the first wave of the fiber, Simon. They send us the plans, PDF, when there's a DWG format. That's of interest to us as well. But if you also have the possibility to provide us with information on how the ridge is finished and whether it's an open ventilation ridge or if it's Tolzinge, so that also helps us to know if we'll be able to attach to that famous ridge purlin. After each signed quote, the design office staff at Fibro-Solar will prepare a final layout plan for you, along with a parts list. The gaps between the columns and along the slope are set by default at 9 millimeters. If you want a larger gap between the columns, don't hesitate to let us know during the preliminary study. We'll see whether it works or not. But along the slope, you won't have a choice. It's our mounting system that results in a 9 millimeter gap along the slope. Based on your roof and its dimensions, will determine the size of the generator for you. We'll deliver rails that are 4.40 meters long. Of course, for your project, there's a good chance you'll even need to cut these rail lengths. You need to be very careful about where your cuts and splices are, because along the slope, all your rails are spliced. As for the various and distinct components of the comprehensive Fibro system, you have robust supports, essential splices, sturdy rails, and secure fasteners, each playing a crucial role. Let's take a quick pause to show you. Here we have a small model with a first support already in place. To attach the supports, actually, upon request, we provide you, it's optional, the wing screw, which is very important. It's a wing screw and an aluminum washer, so it's self-drilling. You drill directly into the fibro if the wave isn't already occupied by another fastener. You will drill straight through the fibro, no need to make a pilot hole, and into the purlin. This little wing actually needs to go through the fibro because it's what will slightly enlarge the hole. You should know that with fiber cement, you always need a hole that's bigger than the diameter of your screw. Here are the two types of supports I showed you, a 10mm gasket or a 3mm gasket, and your self-drilling screw, since you'll be inserting it here, which goes through. And when you fasten your support here, you'll be compressing it. So there's no torque or tightening involved. It's really about the shape. When you compress it, that's when you'll notice if you've compressed it too much or not enough, and it's this that will ensure the watertightness of your project. The intermodule fasteners with the clip allow for contact between the module frame and the rail underneath. This is for grounding the module. Your rail, here, a small sample of the rail. I told you, 4.40 meters. And then the clipping of the fasteners, always with a small edge on the rail. The fastener here, which has this small edge, is always on the spring side. This is where there is some play. This is where you will clip your fasteners. The particularity of these fasteners is that they are not aligned with the rail. So when you install them, whether they're intermodule fasteners or external fasteners, which you'll find at the top and bottom of the generator, always in the same direction, so that there is completely any stagger between the individual fasteners. Aesthetically, it's not nice to see a difference. The small fixed point screws that are provided, we'll see what they're used for in our assembly. And the splices, because you have a splice between the rails, everything is spliced together carefully. We'll look at that as well. Make sure they don't touch at the sliding points. Always leave a 2-centimeter gap. The CTR, which is found at the bottom of the generator, is actually used for your external fastening. It's a support when you're on a slope that comes to rest against your CTR. It's what allows you to lock your generator in place. But it doesn't just serve for that fastening, it also grounds all your rail columns. Here I have a green and yellow wire. Use flexible green and yellow wire. Here, this is an example of a rigid green and yellow wire, but you can also use a green wire just fine. Yellow 6 square millimeters, with a set screw here for tightening. Here you'll make the connection directly between the rail and the green and yellow wire. And then here you tighten it onto the rail. We'll come back to this type of fastening and the optimizers. Before you start, before attaching your supports, before installing your rails, you'll need to check your roof. That means you'll need to check from edge to edge if your length matches the plan you sent us. Will you be able to start? Just like on the plans, meaning at a certain number of centimeters from the edge. So if all of that checks out and you're sure of your measurements, you can make a first mark on your roof to start your first column of rails. Next, you'll need to mark the waves that will receive the supports. And of course, after that, you'll be able to clip your rails in place. So the idea is to create 2 gauges at the length of the module, also accounting for the gap between each column. I'll show you an example of one here. The gap here is either 9 millimeters. We use 9 millimeters by default, but if you want to use 20 millimeters, nothing is stopping you. And as always, your module's end is here, and the gap between 2 module columns is here. So from 0 to 24 centimeters, it's not possible to install a support, but from 24 to 190, you can. You have the option to place your supports. So if you look closely here, your pin can be here. It can be between 2 supports. So for example, if it happens that you already have an existing fastener on a wave crest of the fiber cement, you can simply shift over by 1 wave. Be careful, not in that direction, but here. And of course, make sure not to end up on the wave. You need to be 2 people, of course. You need to be 2 to mark your reference points on the waves. And you will place them end to end your rails. and then you bring in your rails. So you choose to be as straight as possible where your fibers are attached, and then you transfer your measurements each time onto the waves. Use 2 spray paint cans, 2 different colors of spray paint, to mark your waves, but also the gaps between the modules, another column. And then you number your module columns, 1, 2, 3, 4, up to however many you have. This also allows you to lay out your plan directly on the roof and at least keep track of the number of columns. What's important is that if you have 2 rails under each module column, you need to have at least 1 meter of distance, at a minimum, between your 2 rails under the module. Next, once you've marked everything out, you're going to lay out your rails without attaching them to the supports yet, because once you've marked them, you can also go ahead and fix your supports, but you'll lay them out in the shadow groove and then check all your overhangs to see how they line up. What you need to know is that with the Fibro-Solar system, the maximum overhang at the bottom of the slope, the distance between the axis of the purlin or the axis of the support must be less than or equal to 40 centimeters. And at the top, it's exactly the same. At the top of the slope, you cannot exceed more than 40 centimeters. Otherwise, each time you'll have to reach the purlin above. Or if you're not starting from the wall plate purlin, if you start from the second purlin, you'll have to reach the purlin. Maybe the wall plate purlin. And then all the rail splices along the slope should actually be made as close as possible to the purlin. But next to the purlin, that is, you keep a margin of 15 to 20 centimeters. That means your rail should extend 15 to 20 centimeters beyond the axis of the support, so you can make your splice. And once you've checked that on the slope, you can do it on a first edge at the end of your other roof. So if you have 100 meters of roofing, of course, you'll need to check it in several places. You need to check in the middle over distances of 10 to 15 meters to see if you're already well aligned with the purlins. And above all, it's the first rail at the bottom that will determine everything. And for that, you really need to align your rails well at the bottom of the generator, even though, as you'll see, with the solar fiber, you can have a bit of leeway. But be careful, make sure to align all your rails at the bottom of the generator as much as possible. No impact driver. It's a regular screwdriver and not a nut driver either. In fact, impact drivers damage the screw heads, whether it's for the self-drilling screw that attaches you to the purlin. It won't break right away, but after 4 or 5 years, it could break. And it's the same when tightening your modules or the CTRs. You won't see a nut driver or an impact driver being used. First, let's take a quick pause and I'll show you the cantilevers and splices that you can prepare on the ground. The 40 centimeter cantilever we saw earlier, you'll start it with fixed points. The fixed points are 2 small screws that you screw in a staggered pattern. Imagine here that you're at the bottom of the generator, that you've properly aligned your racks, and that you're sure you've set the correct cantilever. Then you come in with 2 small screws here and fasten them. Now this is an example with washers, but normally you don't need washers. It's directly your rail. It slides right in. Be careful. When you set your rail on 2 or 3 supports, it will already be harder to slide. But if you're sure you've checked, you've looked at your diagonals between the first and the second. The rail, the height, the top of the rail, the bottom of the rail. If you're sure about your diagonals, because you can't rely on the screws in the purlin, you can't trust them at the bottom of the fiber cement, since nothing is aligned. But at least you can check your overhangs, no more than 40 if you are. In this case, I would rather put it like this. If your slope is like this or like that, well, no, more than 40 centimeters of overhang. So if you're really on the purlin, the wall plate anyway, generally the fiber cement doesn't extend more than 15 centimeters. And otherwise, if you're on another purlin, no more than 40 centimeters. Of course, no rail should extend beyond the fiber cement, whether at the ridge or at the edge. There is no module that sticks out. It's not allowed. Then you attach it with these 2 small screws, 2 on each side in a staggered pattern. In fact, it will grip onto the fins of the support, onto the rail here, which has a small groove right here. Naturally, once you've positioned it and you're sure about your rail, you clip it in place with your foot or by hand. It just snaps in by itself. If you ever make a mistake, well, you just remove the rail. There's a way to remove the rail. You slide your hands, your fingers just under the rail and pull with a motion like this. So here I won't be able to show you, but you pull it back towards you on all the supports. On the same side, that will unclip it, and then you move to the other side and you can remove it. And once you've clipped it in, I can tell you it won't move anymore. The slides. Before preparing your first rail, you have options. Nothing forces you to do it one way. You can also do it on the roof, but you can just as well prepare your splice on the first rail. If you have 2 or 3 rails on the slope, you can prepare it properly, knowing that here your splice is 8 centimeters. So here you will clip it at 3 centimeters, and it will also grip at 3 centimeters. You need to keep a 2 centimeter gap. So by default, we chose 2 centimeters. You must maintain a 2 centimeter clearance. Here, for expansion, we are working with aluminum. And even on the ground, what you can do when you have prepared your splice is to set up a fixed point. Just one fixed point. On the other rail that you are going to clip, there's no need to put in screws. So to sum up, the fixed points are found on the first purlin at the bottom on the splice. It's just one screw here, 2 screws, and then the next rail that you are going to clip, the next purlin it will meet. Your first rail is fixed. The slides here should be between 15 and 20 centimeters. Whether it's here or there, the overhang should not exceed 15 to 20 centimeters at the sliding points. Bottom of the generator, 40, top of the generator, 40 at the level of the purlins and at the level of the splices, 15 to 20 centimeters. Never splice directly above the support. And it doesn't matter where your module fixing lands, your module fixing can very well be here. It works no problem. So even so, no need to check where your module fixing lands. As I was saying, you will check your diagonals in several places, so from the bottom of the rail to the top of the rail on the opposite side, and your diagonals must be identical before clipping anything. And then after that, you'll be able to put a chalk line either with the CTR, so you're sure the CTR normally you start flush with the bottom rail, but with the Fibro-Solar system, you can have some play, because depending on the rail overhangs, you'll be able to move your generator. Having your rails perfectly aligned is still important to be able to position your generator as well as possible. And it's 5.5, whether it's the fixed points for the supports or the fixed points for your splice, it's a screw. 5.5 by 25 at 2, 8 millimeter hex head. For the splice, 20 millimeters between the 2 rails, the same 5.5 screw. By 25 before or after the support, between 15 and 20 centimeters, never directly on the support fixed to the purlin. And you'll find this little summary actually of what I presented to you regarding the fixed point screws, the splices, and the different supports. As I mentioned at the beginning of this presentation, we need to know what your ridge is like. And of course, on a ridge with a zinc sheet that will come completely flat on the corrugations, we have to put in that well-known 10 millimeter seal for you. So we can bring your rail right up to the edge of the ridge. We can even go onto the ridge itself. Even in the photo on the left, the corrugated ridge, we could very well have attached it to the screws you see here. You can absolutely attach to this ridge as long as it's properly fixed to the purlin, of course. But generally, with fiber cement and this type of screw, there are no seam screws. We really attach directly to the purlin. 10 millimeter support. Please make sure to specify this clearly to us. For the ridge, this is extremely important. What type of ridge? And then the 3 millimeter seal, which is used on all corrugated supports. If you have PST, you will only have this type of seal. One component that we sometimes see on projects is microinverters. What's important with the optimizer is the air gap. In fact, depending on the type of optimizer or microinverter, we'll provide you with a mounting system either with or without a seal. So a screw like the versatile universal mounts or the robust exterior mounts, and with its secure and protective seal right here. And what's important then is the Allen key size 5 for the other mount. And what you really need to carefully check is the crucial air gap right here, as you can clearly see. You need at least a 1 centimeter air gap all around. definitely not pressed against the rail, and definitely not against the corrugation of the fiber cement. Otherwise, your optimizer will break down very quickly. So with this demonstration, you can clearly see, with or without a gasket, the significant difference. Once you've installed the rails and the optimizers, be careful how are you going to install the optimizers, and especially the grounding of the rails, all the rail columns. Mark where your modules will be placed and how you're going to start. At the bottom of the array, are you really flush with the rail, or are you going to raise it a bit higher? But at least you have the layout of the field. You more or less know where you're going to start. But don't put the microinverter where a mounting bracket for your modules will go. And also don't put the grounding with the famous CTR rail there either. Where a module mounting bracket will go, because you'll have to loosen everything and move it all. So all the rail columns need to be grounded for the Fibro-Solar system. And the continuity from rail to rail is done via the splice plates. There's no need to ground any other parts. And of course, you can use 6 square millimeter green-yellow wire or its equivalent. Here we had an example of a marked layout. On each rail column, the tightening torque for the CTR is 2.5 to 3 Newton meters. Be careful with grounding the CTR. Here, when you ground your part, what's important is that when you tighten, you don't go all the way to the stop. So use a 3 millimeter Allen key here. We went straight into the core. Very quickly you reach the copper, in any case you tighten it. As soon as you feel a slight stop or a hard point, you're already grounded anyway. You've already made the connection. And above all, don't over tighten, because you really don't want your set screw to come up against the aluminum. Here, because you'll create contact between the copper and the aluminum, and that's not a good combination. So that's forbidden. Universal fasteners and exterior fasteners, clamping force 10 Newton meters and a 5 millimeter hex key. The fastener parts and CTR for installing the modules. Your lower CTR of the generator should normally start right at the edge of the rail. You can, if necessary, adjust by a few millimeters, between 0 and 10 millimeters, but keep in mind that your CTR, it will be right at the edge of the rail, TLM of 3, as we can see here. TLM of the 3 of them. At the edge of the rail, generally, you have a bit of play. The outer fastener will go here, no matter which direction, here or there, but you need to make sure they are all oriented the same way along the slope, right at the edge here. And then the universal fastener, which you can prepare well in advance before installing the modules, goes here. And you'll be working in this direction with the fasteners here. And your modules will come up against the outer fastener first, and you will slide your universal fastener in. Here, under the frame of the module, with this special clip that will make contact with the underside of the module frame, and your fastener and your rail. This is to ensure the proper grounding of all the modules. So there must be at least 70 centimeters of rail extending beyond the end of your module and your rail. And then at the top, it's 50 millimeters, so 5 centimeters between the end of your rail and the start of your module frame. Tightening torque for these two parts, the universal fastener and the outer fastener, is 10 Newton meters using a 5 millimeter hex key. So the main thing to remember from this presentation is, above all, do not use this overlap wave, this first wave. The upper and lower overhangs of the generator, meaning the rail in relation to the purlins, are 40 centimeters. The splices should be made neatly near the purlins, but the splicing can be done either before or after. The purlin should be about 15 centimeters from the axis of the support or from the axis of the purlin. Fixed points, when I talk about fixed points, this refers, for example, to a screw support. You should know that you will find this fixed point on all the rails. If you have 3 rails on the slope, you have 3 fixed points. Always with 2 small screws in a staggered arrangement, securing both the rail and the support. And then a fixed point screw for the sliding part. Clamping section for the modules, so the fastenings for the modules are 10 newtons, and clamping section for the CTR is 2 to 3 newtons. Let's take a look. A few examples of layout. So we always provide you with a final layout along with a parts list. We check, for example, here on this project, we could see if there were any outlets at the ridge level. We see some eclipses. PST rail support, it's called PST rail support. In fact, you don't really have any. So that truly means that in the end, if we carefully look at the project, are we truly stuck at the ridge? Well, we will see it at the rail. Yes. So you see, this is an interesting example. That's why we started from the purlin, from the wall plate up to the ridge, and your modules here, they were installed. For example, we took 7 centimeters there, but nothing stops you from moving the generator up to have it more centered. Afterwards, you have to be careful. Did we do that? A calculation note might also have prohibited going any higher. You have to be careful. Sometimes there are calculation notes that forbid being too close to the ridge. So keep all of this in mind when you're doing your study, when you're placing your modules. Be careful. We've made plans for you. There's a calculation note. Can we or can't we? There you go. But in any case, you at least have some leeway to raise your generator, or nothing says you can't raise it and center it. And that needs to be discussed first with our technicians at Fibro-Solar. And then there, in fact, if you look closely, you were provided with 3.40 meters rails, but you had to, in fact, cut them. In each crawl, you don't have a whole rail. And in fact, you have, before cutting anything, you will have to go and check on the dish to see where you fall. And maybe the reason we couldn't actually use our 3.40 meter rails is that there was too much overhang compared to certain purlins. You always have to be, as I was saying, between 15 and 20, and above all, make sure there's a gap. So here you can't see it very well on the PDF, but you do have your gaps, which are properly set at 20 millimeters between each rail. There really are those well-known 20 millimeter gaps. But always pay very close attention to these critical splicing areas right here for optimal results. And here, to never be. Here on our plans, we show the purlins in blue. You can see here all of this. These are your purlins. Normally, we also provide you with the purlin spacings. On the other side, on the plan, it tells you that the 4.40 meter rails need to be cut to size. But be careful, always double check. Don't go cutting your rails without first checking how they line up on the roof. Don't go making your cuts and then realize you haven't checked anything on the roof at all. Make sure to check everything properly on the roof. For example, here, since we don't see a very large overhang, there's nothing stopping you from adding a bit more. Here we've put 3.60 meters. It's not a big deal. If you put 3.70 meters, as long as you don't go past the ridge, there's nothing stopping you from adding a bit more. It's especially the splicing areas where you need to be careful. Another example, same thing. Here, in my opinion, you can center it because we can see there's very little clearance at the ridge, but it needs to be secured from top to bottom. But there's nothing stopping you from raising the generator to center it more. That way it gives you some margin. If you raise your generator here, you can easily prepare your CTRs and run a chalk line between the first rail column and the last rail column. You place your first CTR and your last CTR on each column. You set your chalk line, and that way it gives you an alignment for the CTRs and your first exterior fastenings. That's important. And then same thing for your cut. And again, when you go to install it, your cut can very well be done afterwards. So you need to check, because here we see there's a 4.40 meter rail. So your 4.40 meter rail, why did they start it from the top? Maybe for you, that's something to check on your roof. Nothing is stopping you from putting the 4.40 meter rail at the bottom and seeing how it lines up with that purlin. That doesn't matter. What really matters is checking your alignment here. So here there's a, which can be avoided. So that's quite interesting. Then with your 4.1 meters, you'll have some leftover rail, but at least you can always use 4.20 meters or 4.15 meters. But above all, be careful, 15 to 20 centimeters here, your junction between the rails and in relation to the axis of the purlin. So for project 3 here, we can see that a support was tested. So you're on a support call where, in my professional opinion, the client specifically mentioned that your ridge was completely flat. And here we highlight in red whenever there are reinforcements in relation to the number of rails. Here, what we actually see is, of course, your first column. So each edge column, 3 rails. Be careful, we've indicated the distances. There is a distance that needs to be respected. If you come even closer to the edge, maybe you'll need 4 rails. So pay attention to these measurements. Double check your roof dimension. Was it really 60 meters? What is your generator like? So for us, it's around 58 meters 40, a bit more, and see how you're going to start. But be careful about that. So we did a calculation note, really taking all these elements into account. So be careful. So 3 rails. Same here, you have a rail. Maybe you can't see the colors very well, but generally the 4.40 meter rails are orange. So same here, it was checked with an overhang that should be around 15 to 20 centimeters. So there's no need to cut the first rail. The second one was cut, and here we're attaching between the ridge purlin and the second to last purlin, at least on 2 purlins. And again, pay close attention to your existing overhangs, like right here, for example. And here, see how things will line up. Check your overhangs here to make sure there isn't too much overhang. So make sure to check carefully before cutting anything to see how your rails will line up. You can even place your full rails along the slope, then see where you'll need to cut. And above all, make sure everything is properly aligned here. But still, you see, often with Fibro by default, we might set your modules at the bottom of the array, but nothing stops you from raising your whole array by a few centimeters. That way, there's no problem with fixing and installing the first CTR, for example, here, the first CTR on each rail here. Here, so on each individual rail, but you align directly and precisely between the very first and the very last rail with a CTR, which is a crucial component. Then, after placing your CTR, you'll install your outer fasteners, and nothing stops you from putting one in advance. And so on for your modules. So always the first row at the bottom of the array to be set at the level of the modules. That's it for these explanations. Feel free to visit our website to download the TN. We often make module addendums, so don't hesitate to check if the module is part of your project. And for that, it's the same. You have a little Fibro-Solar link, a small search engine on the Fibro-Solar website. In fact, you can simply enter the reference of a module. So I'm going to enter one at random. It will show you all the module references. I'll pick one here. Now, I can't guarantee that it will be part of the Fibro. But in any case, there you go. It will show you the different systems, with which systems. Actually, this module has been certified. And here, for example, we can see Fibro. Take a good look at the power ranges of your module. It might not be included, so be careful. Check regularly, especially if you have a Fibro project or something else. Especially for systems with ETN certification, we regularly update the modules. There you go. We've reached the end of this presentation. So after watching this, you'll automatically receive your certificate once you've entered your contact information. And if you have any questions, I'll leave you my email address. Don't hesitate to leave your comments. And above all, if you have a project, send the project number starting with F or E, your questions, your company name, and your name. Well, all that's left for me is to wish you a great start to your project site. And see you very soon. Goodbye.